Right guys, let's have a look at question 10, which involves differentiation. So here we are given a solid circular cylinder, okay, has radius r centimeters and height h centimeters. We know that the total surface area is 800, so we know straight off the bat that the surface area equals 800 centimeters squared. Show that the volume of the cylinder is given by this expression. Now, of course, what the first thing we should know is that when we're given a total surface area, that means we need to find the expression of the total surface area. So let's picture a cylinder, yeah? A nice simple cylinder. Okay. To work out the surface area, I mean, if you don't know this by heart, I would recommend that you consider just taking, one portion of it. Notice that when we do curved surface areas, we look at the diameter of this curved area, which we know this part, the diameter of it is 2 pi r. We also know that there's going to be several layers of this diameter. In other words, there's going to be h lots of this diameter. So it's therefore going to be 2 pi r times h. That's the curved surface area. And here we are, we just simply got two circles, each using the pi r squared formula. So these are just regular circles, pi r squared. In other words, the areas of the circles. And that's it. So the curved surface is therefore the sum of these guys. So hence we have SA equals pi r squared plus pi r squared is 2 pi r squared plus, and the last one, 2 pi r h. And here you can just factorize. You can just therefore say we have 2 pi r, take r out here, so we've got r plus h. And this would be equal to 800. Now what do we need to find? So notice here that they're trying to get rid of h. So here all we have to do is pretty much eliminate h. So dividing this across and subtracting r, we should have 800 over 2 pi r minus r, it would equal h. Okay, good. Now for the volume of a sphere, of a cylinder, it's just simply pi r squared h. In other words, pretty much, yeah, so pretty much it's pi r squared h. And all we have to do is this h is just replace it with this term. So therefore we're going to have pi r squared bracket 800, yep, hold on, 800 over 2 pi r minus r. And I said now we just expand this and we should get this expression. So expanding this, what do we get? We're going to get 800 pi r squared over pi 2 pi r minus pi r cubed. And now we just cancel out. So we cancel the pi's out. So let me just change the color of the pen. So here we get the pi's go, bang, bang. 1r goes, and we cross out, divide by 2, we get 400 here. Hence, we should get 400 r minus pi r cubed. And that's it, guys. That's pretty much how you do this first part. Okay, so now let's move on to the second part, part B. Okay, part B. So here we are. We need to find the maximum value of V to the nearest centimeter cube. So all we have to do really is use our volume equation and use calculus. Calculus implies use differentiation integration. Because we need to find the maximum value, we have to use differentiation. Okay, so without further ado, let's go. So using the V equation, we need to differentiate this with respect to r, so it's quite easy. So we're going to have dv over dr, which is going to be 400 minus, drop the power of 3 down, we get 3 pi r squared. And now we can just set this equals 0, because taking the derivative means you can set the entire equation to 0 and find the value of r. So plusing this term across, we're going to have 400 equals 3 pi r squared. And lastly, dividing by 3 pi and square rooting it, you're going to have r equals 400 over 3 pi square rooted. Okay, not bad. So of course we're going to round this up to the okay, actually no, we'll leave it like this. Now all we have to do is, using this value of r, we simply plug it back into the volume, because we want to find the maximum volume. Hence the maximum volume for this value of r, oh yeah, so it has to be plus minus, yeah, let's never forget that. For this maximum value, for this value of r is going to be 400 times r, which is, again, so let's just stick with the positive value because you want to maximize the volume. Minus 3. Okay. So yeah, we need to confirm whether this is a maximum or minimum. 400 over 3 pi cubed. Okay. So now putting this in the calculator, what do we get? And you should get, according to my calculator, so we want to the nearest centimeter squared. So this would give us 1737 centimeter cube. Now, how do we justify that this is actually a maximum? Well, we just have to differentiate again. So d2 over dv over dr squared will give us, so differentiating this original equation, remember, yes, always go back to the original equation. So differentiating 400, we get 0. Differentiating this part, we drop the power 2, we just get minus 6 pi r. And to show that it's a maximum, the value must be less than 0. To be negative, this r value needs to be positive. So we need to put minus 6 pi r, which is going to be plus 400 over, why is this doing this? Over 3 pi. And this will guarantee to be negative. You can test it, but it's definitely negative. And that's it, guys. This pretty much justifies the maximum. If you have any other questions, please let me know. Yeah, I mean, if we put a negative value, it's going to, the whole term will end up becoming positive, which is not what we want here. But otherwise, see you guys soon, and let me know for any other problems. Ciao now, guys. Bye.